Okay, class, dictionaries in Python. Okay, this is just a introduction to dictionaries in Python. So dictionaries are a lot like lists, except lists have indices, and dictionaries really have a key and a value. Just like in a dictionary, how you have the word and then the definition. In the same respect, there's keys and values in dictionaries. Okay, the keys must be unique, and you cannot change them. That's what immutable means. But the values, they don't have to be unique, and you can change them. How do you do that, and what's the syntax? It's the following. So this is how you create a dictionary. You say D equals, and D is the name of the dictionary, and we open our curly braces and close them, and then each key value pair is separated by a comma. So our key is A, and our value is 1. And our second key is B, and our value is 2, in no particular order. Now, what happens if we do D of A equals 4? Here are your 4 options. Okay, so the first option is that we add another key value pair. We have A1, B3, and then A4. But this violates one of our rules, that the keys have to be unique. So if I look for the key A, I get 2 possible values, 1 and 4. So that breaks our rule, so it cannot be A. What about B? A is 4, and then B refers to 3. That's pretty much right. This is the answer. But let's look at C. What's the difference here? It's basically 1 plus 4 is 5. That's definitely not the truth. Okay, a key A already has a value 1 assigned to it. Now this intuitively makes sense, right? If we try and add a key A, who knows? Maybe there should be an error. But to convince yourself that that's not the case, just write it out here. D equals A equals 1, B equals 3, B refers to 3. If I try and select D of A, by the way, use square brackets here, just like you would for an array, except instead of the index, we put the key. And if we run our code, as you can see, A has been changed to 4 from 1. Okay, let's comment that out. And that refers to our next slide. Okay, what if I have a dictionary, same as before. I changed the key A to 4. That'll change to 4. We already know that. And then if we add C, will it fail? Can we add something to the dictionary like that? Turns out that we can. So in this case, we already know that A has to equal 4. And B doesn't change. And C, it says 0 here. That happens not to be the case. In this case, C equals 8, B equals 3, and A equals 4. And as you can see, it's not in the same order anymore. It doesn't get added to the end. And the truth is, I believe it's C, because dictionaries do not have an order. Finally, there's error. There's no C and D. Error for some reason other than the one stated in D. So let's just take a look and convince ourselves of that. So if I run this code, we know that A refers to 4, B refers to 3, and C refers to 8. It's a little bit different from this, but it doesn't even matter because there's no particular order. Like this doesn't have to be 1, 2, or 3. I just wrote it in this fashion to indicate to you that it doesn't matter the order. As long as the key, there's one key and refers to a value, everything's good. Alright, what about this? This is exactly the same code except C plus equals 1. What's going to happen here? If we run our code, like what is D at C? There is none. So it looks like there's going to be an error. And to convince yourself of that, oops, to convince yourself of that, right here's the code. And if we mark our code, we got an error. Key error C. There is no C in D. So it automatically fails because I'm trying to refer to something that doesn't exist. Comment that out. Alright, so here are some things that you should remember. Keys must be immutable. You can't change them. Values can be muted or immutable. That's the value. Use dk equals v to add a key k with a value v to the dictionary. If k is already in there, the value is overwritten. To copy all key value pairs from another dictionary, use the update method. And use dictionary dict to shallow copy another dictionary. We'll have that and more information about that later. We can update the dictionary so also work with a sequence whose elements are of length 2. Okay, so we'll look at that later. Printing dictionaries. You can say print D, as we've been doing automatically over here. Print D to show the dictionary. Now what if I wanted to, and we can say print dk to print value of k in dictionary D. We can also use a loop to print out all keys in a dictionary. So for key in dictionary, print key. So the key will take on every key value in the dictionary. Now, what about in this case? What if we wanted to, this is an example. So k takes in the value a and takes on the value b. What if you modify this to print out the values? Well, you'd have to put, d at k. And we did that in right over here to show you that. So a is 1. If I was to print k's, it'd be ab, but k takes on the value a, so d at a is going to be 1 and then 3. If I run my code, I see that it's 1 and 3. If I only want to print k's, for k and d, it'll print all the keys, a and b, right there. Now, what happens if I try and print nothing? It gives me an error because there's no C in D. That's what the next slide is about. Okay, but it introduces the concept of, so use KD to obtain a value associated with key K in dictionary D. If K does not exist, it causes an error. That's what we got. Now, there's something called the get method. Returns a thing, except it never causes an error. It'll return none. If it does not exist, none by default. You can supply a second parameter to make it return, to get the method, to make it return something besides none when the key doesn't exist. And we'll see an example of that over there. So if I print AZ, like I said, we did that earlier, it gave me an error. Now what gets printed out with this code? Print get AZ. Sorry, A get Z. Well, if we use Z and it's not there, what do we get? We get none. And we can see that over here. Oh, we can see that over here. Let's not give a second parameter. And let's run our code. So if I try and get C, it returns none. The second parameter is what gets returned if we don't find C. So default is none. If I don't have a parameter here, nothing gets sent. Otherwise, 8 gets sent. Alrighty. So in this case, I'm trying to find get A get X. What gets returned? Well, at X we get 1, right? So the answer is actually 1 here. And if I didn't find that X key, then we'd return 0. Alright, so here's an exercise to try and look over on your own. Go ahead and try and do that. I will cover that right now. So, we have 3, 4. That's this right here. Then, we say A5, that's the key, D up 5, is equal to, well, whatever that is. So, we're going to try and get the value of key 4, but there is none. And if there isn't any, we put the value 8. So that turns out to be the case. It's true. Then next, we say D of 4 is get 3. And if we don't find it, we put a 9. But we do have a key 3 right here. So the key 3, we find it. So D4 should equal to 4. Here it says 9, so that's not true. So we need 3, 4, check. 5, 8, check. And then 4, 4. Let's see if that's true. So we'll see. We'll look at it one more time. So we'll look at the second one. Erase pen. Let's look at it again. We have 3, 4. That's created. D of 5. That's my key. Equals D dot get 4 dot dash 8. So is there at key 4? There is none. So we put in an 8 there as a default. D of 4, well, we don't have a D of 4. We're going to create it now. Is equal to, whatever that's going to be, D get 3. Is there a 3? Yes, it is. So don't even worry about this 9. Because we already have a 3. What's the value of 3? Well, that's equal to 4. So it actually turns out to be B. And that's how you do that one. Okay, try this on your own. If you think you understand it, try it on your own. Okay, now that you've tried, pause the video. Now that you've paused the video and tried, D1 of 5 creates, basically they're all the same. So they're pretty much all the same. D of 2, now we're talking about D of 2. We're going to add something to D of 2. Well, we're going to get D of 1. We're going to get D of 1. Well, that's equal to 5. If it doesn't find D of 1, put in 6. But it does find it, so obviously we're not going to do that. Get D of 1. Well, that's equal to 5. So it's obviously, it's not this, and it's not this. Well, let's see. What else is there? D of 4 equals get D of 3. Is there a D of 3? No. So then we set it equal to 7. All right. And get cannot put an error. If we don't find anything, there is no error. And that's how we work with dictionaries. Okay. Now, when do you use dictionaries instead of a list? This question talks about that. Which of the following is best suited for a dictionary instead of a list? The order in which people finish a race. Well, orders work for lists well because you can just add or append to the end of the list. The name of ingredients necessary for a recipe. I mean, even if there's orders important, it shouldn't matter. I mean, it's just a bunch of stuff that goes in a recipe. The names of world countries and their capital cities. So for every country refers to a capital city. So that's a great candidate for a dictionary. And then 50 random integers. No. No and no. So our answer would be C. And that's the end of dictionary lesson for now.